Have you ever wondered why an AI can write a beautiful poem, but totally fumbles when you ask it to just book you a flight? Well, a new paper has a fascinating answer, and it might just change how we teach AI to do things in the digital world.
You see, for a long time, we've basically just been chatting with AI. But the real game changer, the next big thing, is what people are calling Agentic AI. We're talking about models that can actually use digital tools, APIs and software, to get stuff done for you. Booking that flight, managing a project, ordering your groceries. The goal is an AI that doesn't just give you answers, it takes action. But there is a massive roadblock standing in the way.
And yeah, that roadblock, it brings us to the heart of the problem, what I'm calling the AI training bottleneck. To get an AI to do things, you have to train it. Sounds simple, right? Well, it turns out training an AI to use tools is incredibly hard, and it all boils down to a major data problem. The authors of the paper put it perfectly. Our progress is being held back by a huge shortage of something called agentic data. Just think about it. For you to learn a skill, you need to practice, right? Well, for an AI, practice is just data. And the specific kind of data it needs to learn how to use digital tools is incredibly rare and super hard to get your hands on.
So what exactly is this agentic data? Well, it's not just random text from the internet. It's more like a flight recorder for an AI's brain. It's a step-by-step log of the AI's entire experience trying to complete a task. These logs, or trajectories as the researchers call them, capture every single tool it used, every button it pushed, and what happened in the end. It's a detailed record of the AI trying, failing, and hopefully succeeding.
And this slide really lays out the dilemma. The old way of getting this data was frankly painful. You'd have humans manually creating these little practice scenarios. It was slow, it was expensive, and you could never create enough variety to cover all the things that could go wrong. What we really need is a new way, a method to automatically generate millions of diverse, realistic practice runs where we can know for sure if the AI actually succeeded.
Which brings us to the paper's brilliant solution. If you can't find enough real-world playgrounds for your AI to practice in, why not just build a factory that can churn out an infinite number of virtual ones?
And the core idea behind this factory is actually a really powerful, simple insight. The researchers realize that any digital tool an AI interacts with, whether it's an airline's booking system or a simple to-do list app, can basically be boiled down to a database. The AI performs read actions, like checking to see if a flight is available, and write actions, like actually booking the seat. That's it, and this simple idea is the key that lets them scale everything up.
So how does this factory actually work? It's a pretty slick three-step process. First, they just vacuumed up a massive library of over 30,000 real-world APIs. Next, they used AI to figure out how all these tools relate to each other, clustering them into logical groups or domains like travel or shopping. And then, this is the magic part, they automatically converted each API's description into actual working code that could interact with a simulated database. They essentially built an infinite supply of verifiable flight simulators for AI agents.
Okay, so the factory can crank out endless sandboxes for the AI to play in? Awesome! But how do you make sure the AI is actually learning the right stuff? You can't just let it run wild in there and hope for the best. You need high-quality, structured practice.
The way they do it is by simulating the whole back and forth. They create a simulated user who has a specific goal, like, hey, I need to return this shirt I bought last week. Then, the AI agent has to figure out which tools to use in that particular sandbox to make it happen. And this entire interaction generates those precious experience logs, the agentic data we were talking about earlier.
But here's the thing, not all practice is good practice. To make sure only the best of the best experiences are used for training, the researchers built this super rigorous three-stage filtering system. The first filter just cleans up basic mistakes. The second one is smarter. It actually checks the database at the end to see if the AI really accomplished the user's goal. And the final filter is the strictest of all. It makes sure the AI not only got the right answer, but used the most perfect and efficient sequence of tools to do it. Only the absolute gold standard runs make it through.
Now, with this super high-quality data, they use a really clever two-stage training plan. In stage 1, the agent is like a student in general studies. It learns the absolute basics of how to use tools across thousands of different domains. It becomes a generalist. Then in stage 2, it's like a resident specializing. They fine-tune it on very specific areas, turning it into an expert, like a master travel agent or a pro retail assistant.
Okay, this is all incredibly clever. The engineering is fascinating.
But let's be real, the only question that matters is, did it actually work? Can this whole new way of training produce a better AI agent? Let's take a look at the results.
So say hello to AgentScaler. This is the new family of AI models they built using this environment scaling method. They trained a few different sizes, and then, to see how good they were, they pitted them against some of the biggest, most powerful AI models on the planet.
And what happened next was a total David versus Goliath moment. On a really tough benchmark for airline booking tasks, the 30 billion parameter AgentScaler model scored a 60. A major competitor, which has over 1 trillion parameters, that's more than 30 times bigger, only scored a 56.5. Get this, AgentScaler didn't just keep up, it actually won. It's incredible proof that smarter training can absolutely beat brute force size.
And you can see the magic of that two-stage training right here on this chart. The base model, before any of this special training, started out with a score of about 67. After that first generalist training stage, it jumped up to 72. And then, after the specialist training, it got another big boost to almost 76. It's just crystal clear proof that every step in their process added real measurable power to the AI.
So, no doubt about it, this is a huge breakthrough. But like with all great research, solving one big problem usually just reveals the next big challenge on the horizon. And this paper points us directly toward the next agentic frontier.
And that next big challenge is what the researchers call the long horizon problem. What it means is, while AgentScaler is amazing at tasks that only take a few steps, its accuracy starts to fall off a cliff as the tasks get more and more complex. Keeping a coherent plan together over many, many steps is still a really hard problem for all AI agents out there.
And these numbers make that problem painfully obvious. Look, for simple tasks in their retail test that take, say, 2 to 4 steps, accuracy is a really solid 82%. But as the tasks get longer, look at 8 to 10 steps, the accuracy just plummets down to 40%. The longer the chain of actions, the more likely the agent is to get confused and mess up.
And yet, the big takeaway from all of this is actually really optimistic. It suggests that the best way to get more capable AI agents might not be to just keep building these monster trillion-parameter models. Instead, the future might actually be in smaller, smarter, more efficient models that are trained in way richer and more complex virtual worlds. Which leaves us with a really interesting question to chew on. As we try to build these truly helpful AI assistants, is our biggest challenge really building bigger digital brains? Or, as this research suggests, is it actually about becoming master architects of building better digital playgrounds for them to learn in?